Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video on two-way tables. So two-way tables basically do the same thing as do Venn diagrams. What they do is they show you how many things are in each set, both sets, neither set, or whatever. And we do that as a tool to help us with probability calculations. So let's look at an example. So we'll try this example here. So 200 students in year 9, 180 passed maths, 150 passed English, 12 passed neither. And we are wondering, if we select a student at random, the probability that they pass maths but not English. So once again, we're doing a probability question. That's what two-way tables help with. So you probably know that we could put all of this information in a Venn diagram just like we did last lesson. So if we set up our Venn diagram, they always look the same. We have a rectangle, two circles for the two sets. Set A, they pass maths, and B, they passed English. So we know how to do this. Remember what we did was we did 180 plus 150 plus 12. We added up all the numbers that we're told about, and of course that equals 342. That means we've overcounted by 142 because there were only 200 students. So we put 142 in the middle. So there's already 142 in the maths circle, so we need another 38 in the maths circle, and we need another 8 in the English circle, and of course 12 who pass neither go outside. And of course 38 plus 142 plus 8 plus 12 equals 200. So that's a Venn diagram. So two-way table is basically presenting the same information in a different way. Set up a table, that's why it's called a two-way table, and it's a 4x4 table. So it has 4 rows and 4 columns. So the two ways of the table are the two sets. We can either be in A or not in A. That's what A dash means. And B or not B. So what the two-way table has that the Venn diagram doesn't have is we usually have a row and a column for totals. So we can put that same information here. So this cell here means we're in A and B, so they pass maths and English. So I already figured out that that's 142. The next cell down here means we're in A but not B, so we pass maths but not English. And then the number of people who passed English but not maths, and then who passed neither. Of course, we note there are always 4 numbers in a Venn diagram, and they are the same 4 numbers that we'll see in our two-way table, but we might just fill out the totals as well. So we have 180 and 20, which equals 200. And 150 and 50 also equals 200. So the Venn diagram and the two-way table give us the exact same information. So now we can answer probability questions easily. What is the probability they pass maths but not English? So let's go to the cell where it's maths but not English. Maths but not English here because we're in the past maths column, and we're in the didn't pass English row. That's why it's 38. So the answer would be 38 out of the total, which is 200, or 19 over 100, 19%. How easy is that? So let's look at one more example where it would be easier to use a two-way table than a Venn diagram. So this question here is quite wordy, but it's really easy. Survey of 500 teenagers, 300 of them are boys. We ask them whether or not they exercise regularly. 420 exercise regularly, and 60% of those who exercise regularly are boys. We're going to calculate the probability that if we select someone at random, they are either a boy or someone who exercises regularly. So what we're going to need to do is we're going to need to display this information so it's really easy to see. So we have here 2 sets. So the first set is talking about whether or not the person's a boy or girl. So we have B for boys, and not B means that they're a girl. So we also have the set whether they exercise regularly or don't exercise regularly. So recognizing that this question involves 2 sets allows you to say, okay, I'm going to use a Venn diagram or two-way table to display the information. So we've got that. We know that it's two sets involves. People can be in one set, both sets, neither sets, whatever. That's why Venn diagrams or two-way tables are helpful. Now, a two-way table here is more helpful than a Venn diagram because we're given information about the total that are in each category. It would be a little hard to draw a Venn diagram because if I looked at, say, the circle that's boys, I don't know how many of them go in the middle and how many of them by themselves. So I want to draw a Venn diagram. If I say I have, B and E, I know that there are 500 in this circle, but I don't know how many to put here and how many to put here. But two-way table will be easier because it lists the total in each set, whereas a Venn diagram doesn't. So we draw up our 4x4 table. So the two ways we have, they're either a boy or not a boy, exercise regularly or doesn't exercise regularly. So we'll now fill this out with numbers. So we have 500 people in total. We know that there are 300 boys. We know that there are 420 who exercise regularly, and 60% of these are boys. So 60% of 420 is 0.6 times 420, which is 252. So 252 of those who exercise regularly are boys. So these four numbers are all we need to fill in all the other numbers. So we know, for example, in this cell, it's just 300 minus 252, which is, of course, 48. We know here would be 420 minus 252, which gives us 168. So we have 80 here, 32, and 200. Everything adds up. So I know I've done something right. 300 plus 200 is 500. 420 plus 80 is also 500. So now let's answer the question. What's the probability they're either a boy or someone who exercises regularly? So remember that word or. Or either a boy or someone who exercises regularly means they're a boy, someone who exercises regularly, or both. So looking at our two-way table, we need to include all the boys and all the people who exercise regularly, and we definitely include both. So we need to include all of these three cells. So the probability of picking someone at random who fits that criteria, either a boy, someone who exercises regularly, or both, it's 252 plus 168 plus 48. That's the total. The categories, we just divide that by 500 because that's how many were there in total. And so the answer is 468 over 500. And we could divide by 4 if we wanted. We get 117 over 125. So the two-way table made this calculation so much simpler. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.